Dear students, I am Nilanjana Sanyal, an online math tutor from India. Today we will be solving this question. This question was given to me by one of my students who was pursuing the IB MYP curriculum at that time. So the question says, consider the sixth degree polynomial f of x, which is equal to 20x to the power of 6 plus ax to the power of 5 plus there are some terms in between and the last term is plus 140, where a belongs to the set of integers. And the roots of the polynomial are obviously, since the polynomial is of 6th degree, there will be 6 roots. So the very first root is log of n squared to the base m. Second one is log of n cubed to the base of m square. Third is log of n to the power of 4 to the base m cube. And the last one, the sixth root, is log of n to the power of 7 to the base m to the power of 6, where m and n belongs to the set of positive integers. Show that m is equal to n. Okay, so let's start answering. Now, first thing that we notice is that the roots are having different bases. The first one is to the base m, the second is base m square, the third is base m cube. So let us convert them to the same base m. Okay? And also let us take the powers to the coefficient position. So for the first root, it is log of n square to the base of m. This can be written as 2 times log of n to the base m. Okay? So this is having the base m, so we don't have to change the base. For the second root, this is the first root. The second root is log of n cube to the base m square. So we can change the base. So it is log of n cube to the base m over log of m square to the base m. So this can be written as 3 log n to the base m over 2 log m to the base m, and log m to the base m is obviously 1. So this is practically equal to 3 over 2 log n to the base m. This is the second root. What about the third root? The third root is log of n to the power of 4 to the base m cube. So this is equal to 4 log n to the base m over log m cube to the base m. So this is equal to 4 because the denominator is equal to 3. Therefore, we can write this to be equal to 4 over 3 log n to the base m. This is the third root. And they have given the sixth root, so let us write the sixth root in this form. So it is log n to the power of 7 to the base m to the power of 6, which can be written as 7 log n to the base m over log m to the power of 6 to the base m, which is equal to 7 over 6 log of n to the base m. This is the sixth root. Okay, so we have got the first root, the second root, the third root, and there are 2 more roots, but we can write the other 2 also seeing the pattern. but we do not need actually, so we can write these 4. We can take these 4. Okay. And now coming to the polynomial f of x. Since f of x is a polynomial of degree 6, it is having 6 roots. So this can be written in root form as k is any real number and x minus the first root. 2 log n to the base m times x minus the second root. 3/2 log n to the base m times the third root x minus 4/3 log n to the base m, and there will be the fourth root and the fifth root, and there will be 2 more factors in between, and the last factor is x minus 7/6 log n to the base m, which is equal to the given expression, that is 20x to the power of 6 plus x to the power of 5 plus ... plus 140. Okay. So now coming to the coefficient of x to the power of 6. We get the coefficient of x to the power of 6 from this expression. So we are seeing that how can we get x to the power of 6? If we expand the whole thing, we don't have to expand entirely because it will be taking so much of time and we do not actually need it. But we can see x to the power of 6 can be obtained when these x get multiplied together. So x times x times x times x times x times x will be giving you x to the power of 6, and k times x to the power of 6 is the term containing x to the power of 6 on the left hand side of this equal to sign. So k times x to the power of 6, if we equate the two terms containing x to the power of 6 from both the sides of the equal to sign. On the left hand side it is k and x to the power of 6, and on the right it is 20 x to the power of 6. So obviously k is equal to 20. We are getting the value of k to be equal to 20. Okay. So now we can just modify this, and in place of k we can write 20 and the remaining things stay as it is. It is log n to the base m x minus 3/2 log n to the base m x minus 4/3 log n to the base m, and 2 more factors, and the last one is x minus 7/6 log n to the base m. Okay. Now I'm seeing we do not know the value of a, so I'm not taking this term, but we know the constant term. It is plus 140. Okay, because we have to show that m is equal to n. I don't think the second term x to the power of 5 will be helping us in any way, because the value of a is not known to us. So I am taking the constant term. And how can we get the constant term? The constant term can be got from multiplication of the constant terms of the 6 different factors and the 20. So the constant term will be 20 times minus log n to the base m minus 3/2 log n to the base m minus 4 over 3 log n to the base m, 2 more, and then the last one is minus 7 over 6 log n to the base m, and this is equal to 140. Okay, so if I divide both the sides by 20, I have this to be equal to 7. Okay, and these two get cancelled. And now what about the product? First of all, what is the sign of the product? Over here, I am seeing obviously there will be 6 factors. There are 6 roots, so 6 factors. So if we multiply minus 1 times 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 minus 1 means 6 minus 1s. We will obviously be getting a plus product, that is a positive product. And obviously we are seeing this is plus 7. So it is a positive number on the right hand side of the equal to sign as well. So now coming to what is the product of the left hand side. Now if we see the coefficients, one thing is common, that is log n to the base m. This is getting multiplied 6 times, so this is to the power of 6. Now what is the coefficient? You see, this is 2 over here in the numerator, 2 is in the denominator. For this, 3 is in the numerator, 3 is in the denominator. We know, we can very well understand what will be the coefficient of the next one, next factor. It will obviously be 5 over 4, and the other one, the fifth one, will be 6 over 5. So this 4 and this 4 will get cancelled, and this 5 and this 5 will get cancelled, and this 6 and this 6 will get cancelled. So what will remain is this 7. So we have 7 log n to the base m whole to the power of 6 is equal to 7, or log n to the base m whole to the power of 6 is equal to 1. Dividing both sides by 7, we get this equation. And on taking the 6th root, what do we get? If we take the 6th root of both the sides, that is the 6th root of both the sides, we get log n to the base m is equal to 6th root of 1 is 1. Okay, and this is a logarithmic equation. Log n to the base m is equal to 1. If we convert this to an exponential equation, what do we get? We get m to the power of 1 is equal to n, which means m is equal to n. Okay, so we have shown that m is equal to m. M is equal to n, or n is equal to m. Okay, so that is how you show that m is equal to n, and it doesn't depend on the values of m and n. M and n can be any positive integer, and this relation that m is equal to n will be valid for every positive integer. Okay, so students, this brings us to the end of this session. We have solved this question. So thank you for watching this video, and please write to me if you have any question which you are not being able to solve and which is related to the IGCSE math curriculum or IB MYP math curriculum or IB or IGCSE or A-level curriculum. Okay? So thank you and bye.